Okay, so you're working on W1.6 and you're a little unsure of what to do. Well, let's get started. First, you've completed Lab 1.3 Personal SI. Hopefully the leprechaun brought you home. And now we can use some of the estimates we made there and others we've talked about to help you out. For example, lengths, it's not a bad thing to remember your Y, M, C, A, or more like your meter, decimeter, centimeter, millimeter. So those are good to keep track of. Masses, well, we had individuals in your class somewhere between 50 and 100 kilograms. We talked about paper clips, a few other things. I'll leave this chart for you. It's best you actually think them through. Look at some of what we did on the back of W1.4. Look at what we did on the lab. And you'll also look at Lab 1.4. That'll end up helping you on this slightly as well. Okay, so the best way to approach these is as follows. Cross out the unreasonable answers, because some of the answers are just plain unreasonable. For example, the mass of a paper clip. There it is, that's a nice problem. Now, unreasonable. Knowing that a kilogram is roughly, all kilograms, is roughly 2 pounds, and knowing that Big Nick is roughly 100 kilograms, you may know a few others, it probably is not that sensible that a paper clip, well, at least your standard operation paper clip, be 10 to the 6th or 1 million kilograms. So that is not a good answer. Also, wholly unreasonable is that a paper clip be 10 to the 3rd or 1,000 kilograms. Now, if you notice in the answer key down on the bottom, first you identified the two totally unreasonable answers. There's usually two that are just totally unreasonable. I then in the key told you for question 1, the answer choices that are obviously unreasonable are choices 1 and 2. And so you can use the key to help guide you to the correct answers. I didn't give you the exact answers in the key because, well, it's not much to write here, so I'd rather you think about it on your own. Now, we come down to the final 2. In general, there are 2 that look crazy, as long as you're looking, and 2 that look like maybe. Upon further thought, one of those is also crazy. Which one is crazy? Well, let's find out. One nice way to think about it is, how many do I need to make 1? And what I mean by 1 is 1 whatever unit we're working with, so 1 kilogram. The reason we use this method is because people typically have a hard time imagining what 10 to the minus 3 and 10 to the minus 6 look or feel like. 10 to the 3rd, 1,000, you have an idea. Million, you know it's big. These two, generally in your head, both fall under small. So how many do we need to make 1? Well, let's figure that out. 10 to the minus 3rd, well, you would need then, multiply this by 10 to the 3rd. You would need 10 to the 3rd paper clips to get 1 kilogram. In this case, 10 to the minus 6th would be 1 paper clip, so you would need 10 to the positive 6th to give you 1 kilogram. And so now we consider, which actually makes more sense, that 1,000 paper clips are equal to 1 kilogram, that's about 2 pounds, or 1 million paper clips is about equal to 1 kilogram or 2 pounds. Well, hopefully it strikes you as more reasonable that it is 1,000 paper clips. 1 million is a big number. You have never counted 1 million of anything. You probably never will. You can look up on YouTube. There may be a guy who actually counted to 1 million. I think it took him like full-time job, all day he would count. It took him like 3 months or something. Anyway, that's the reasonable answer. We can apply the same exact reasoning to question 2, and then I'll leave you to do it on your own. Question 2, let's move down. What is the length of a baseball bat? Okay, where are the unreasonable answers? Well, at first it may not strike you, but take a moment and think. Start on the ends. Well, let's start on this end. 10 to the 2, that's 100 meters. It's a heck of a baseball bat. That's a Paul Bunyan baseball bat. Not a standard operation baseball bat, that's out. Well, let's move on down. 10 to the 1, how many meters is that? That's 10 meters. 10 meters, that's over 30 feet. Baseball bat that's over 30 feet, you gotta have some grip strength. That's out too. Now you look at these two and think, okay, which one could it be? I'm not so sure. Well, hopefully your brain recognizes that 10 to the 0 is actually 1, and that 10 to the minus 1 is actually 0.1. Now, if you remember our song, meters, that's actually decimeters. So is a baseball bat more like a meter or a decimeter? Well, I think you know which one it is. The only reasonable answer, 10 to the 0. Of course, notice just like before, 3 and 4 were crazy. And if you come down here, where are we? Question 2, I actually said 1 and 4. The truth is I could have said more than that. I could have said 1, 3, and 4. They're all kind of crazy. All right, anyway, there it goes. So try the rest of these. Not all of them will be as simple as perhaps the baseball bat, but usually the complexity is not any more than the paperclip. I think you can do it.